I'm going to do this lecture just as I have done the last one. So I'm going to start breaking them up instead of having big herkin long lecture videos for you. What we're going to do now is build on to what we've done before, but now we're going to talk about things about predicting what's going to happen to a solution once I put some sort of salt in it. So is the salt going to make it more acidic, more basic, or like not change it at all? What I want to define for you is what we're calling a salt. So salt is going to be hydrolysis of an ionic compound. And what we're going to see is some of these compounds will behave like bases and some will behave like acids when they are hydrolyzed. So let's take like NaCl. If I take this and I put it in water, what do I get? Well, I'm going to get sodium ions and chlorine ions and water. That's not exciting. But I can ask myself, well, can either of these things interact with the water to form either an acid or a base? And if those things can, then I'm going to have some sort of separate reaction going on where I'm generating an acid or a base. What acid or a base could I make? Oops, what did I just do? This is not a plus. This is a minus. That would not happen if it were a plus. So sodium, the only thing it could do is accept, we have OH minus as our two options. So breaking the water into OH minus and H plus. So the only thing sodium could get together with is NaOH, which is a strong base. And then the only thing the chlorine could get together with would be the HCl, because a negative ion isn't going to bond with another negative ion. It has to bond with some sort of positively charged thing. Well, this is a strong acid. So if the strong acid and the strong base would completely dissociate in water, then that means if I start with something like table salt and throw it into water, I'm not making anything that is acidic or basic. It's just neutral, because these two things aren't going to like reverse a reaction to form sodium hydroxide or hydrochloric acid. So in other words, this is my reaction and nothing is going to happen. Now let's go into things that aren't quite as obvious, and what we're going to depend on that you're going to see is either looking for tables of Ka values or looking at something that gives you like the relative strengths of your acids and bases. So I want to remind you, we looked at this table earlier on when we were talking about our acids and bases. So our strongest acid is up here. Strongest acid is up here. Our weakest base is up here. In fact, here are our 6 strong acids. Whoops. I missed. Poor nitric acid. Got left out, and it's definitely a strong acid. Let's erase that. Erase. So I have my 6 strong acids, and by definition for something being strong, meaning it's going to nearly completely dissociate in solution. And if I draw that line straight over, these are my strong acids. These bases are the weakest possible. In fact, they're like weak, 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 weak times 10 to the 80th. In other words, because they're coming from strong acids, it's just like my example with the NaCl and water, these things aren't going to accept hydrogens. They'd be forming a strong acid, which is just not going to happen. But we can let this table kind of guide us in deciding what reactions are going to be. So let's take a look at a set of reactions that I have for you. What I want you to do is pause and predict what the products are going to be, and then come on back. All right, so let's see. What are my options here? Why did that happen? Let's go back to pen. I don't know why my pen suddenly decided not to be there. I have HNO2, and I can remind myself that this is like H plus and NO2 minus. So can that thing accept another hydrogen? Well, it's already like happy, right? I have a positive charge with a negative charge, so there's no draw for it to accept another hydrogen. That means this is going to act as my weak acid, and then water would act as my weak base. So what am I going to form? If I'm a weak acid, I'm donating that proton, so I'm going to come to NO2 minus, plus, well, water is accepting it, so I'm going to make H3O plus. And I can take a quick look over at my weak times 10 to the 80th bases, and NO2 minus is not on there, so if I've forgotten where it is, in fact here it is, then I can look at the chart to confirm. And in fact, I look at this and NO2 minus is like, I don't know, about midway through. F minus is about midway through between our strong bases and our weakest bases. So it's a weak base. That means if I'm going to produce H3O plus, that this is going to lower the pH, because I'm producing hydronium. Okay, what about this one? I look at this, and the first thing that my eyes go to is this NO3 minus, and I have that as the weak base times 10 to the 80, and I said, so that can't act as a base, but it doesn't have a hydrogen to donate. So if it doesn't have a hydrogen to donate, then that's the only reaction I could actually write is with my cyanide giving up a hydrogen and my HNO3 accepting one. Well, all I've done here is confirm that I've created a strong acid, which won't happen. So if I get to that where the only thing I can create is a strong acid or a strong base, then I can say, nope, not going to happen. Therefore, this is a no reaction. This is the same as putting NaCl. Not going to change the pH at all. All right, what about this one? Well, I see two amphoteric things. I have my HS minus, which can donate a hydrogen, and my HCO3 minus, which can donate a hydrogen. HCO3 minus, I can remind myself, is not part of my strong acids. So that means it can go both ways. So let's write out both reactions. I'll make this first my weak acid and my weak base. If I do that, what do I get? My weak acid is going to give up a hydrogen, so S2 minus, plus my weak base is accepting it. So now I have H2CO3 minus. What's the other reaction I can write? I can do the same thing, but call this my weak base and this my weak acid. So how do I decide if this has happened? Well, let's write out our products. What am I going to get? Let's see, the weak base, that means it's accepting, so I'd get like H2S. And my HCO3 is my weak acid. It's donated, so I get CO3 2 minus. Cool. So what do you think? How can I use the table to the left to decide which one of these reactions is going to be dominant? Think about it and come back. So the one thing I could do is, using this table, is look for which one of the weak acids is the strongest of the weak. Or I can look at which one of the weak bases is the strongest of the weak bases. Remember, a stronger weak base or weak acid is going to have a higher Ka or Kb. So the other thing I could do is look up Ka values and see what I have. But I can look over here at my list and say, okay, where are my acids? So if I want HS to be acting as my acid, where is HS? There it is. It's down here. It's a pretty weak acid. My HCO3 minus, well, this is just above. It's a couple above my HS minus. So that means that my HCO3 minus is actually my stronger of the two. So this is my stronger of the weak acids. That means this reaction is the more likely. And we can confirm that by also looking at our bases. So HS minus is right here. Remember, we're going weaker as we go up. And where is my HCO3 minus? There it is. It's right here, just one above. So HCO3 minus is a weaker base than HS minus. So indeed, this is going to win over my HCO3 minus. So this is going to have a bigger KB. KB is going to be greater, and the Ka here is going to be greater. That is what you want to look for predicting. And now I'm going to stop there, and then we're going to look at some more examples of this.